Introduction. It is summer vacations. Friends have gathered at Mohit's place to play a game of carom. During the game, the electricity went out. Mohit went and brought a burning candle to finish off the game. Everyone had seen a burning candle, but today seeing the dancing flame was interesting. The flame is an interesting topic to discuss. In this lesson, we discuss about the flame and fuels. Objectives. At the end of this lesson, you will be able to explain the structure of a flame, define fuel and fuel efficiency, explain the harmful effects of burning fuel. When we look at a flame of kerosene lamp, it is yellow in color, but the flame of a kitchen stove is blue. It is interesting to know that the color of a flame depends on the oxygen supply. If the oxygen supply is less, flame will appear yellow due to incomplete combustion of fuel. And if it is more, the flame will appear blue due to complete combustion of fuel. Do you know how these flames are obtained? When we burn the candle with a matchstick, the heat of the matchstick melts and vaporizes wax, which rises through the wick and forms flame. A candle flame can be divided into three regions: inner zone, middle zone, and outer zone. Let us watch Rohan performing an activity. He is introducing a glass plate into the luminous zone of the candle flame with the help of pair of tongs. The glass forms circular blackish spots indicating the presence of unburnt carbon particles present in the luminous zone of the flame. Now observe another activity. Rohan is holding a thin long copper wire inside the flame with the help of pair of tongs. The portion of the copper wire just outside the flame is getting red hot. This indicates that the non-luminous zone of the flame is the hottest part of the flame. Let's check what you have learned. This is a candle flame. You have to drag and drop the correct zone in the respective box. Fuels are an important source of energy. We use petrol or diesel for driving car, LPG for cooking food, crude oil for flying an airplane, and wood to provide warmth. All these are fuels. All fuels do not burn efficiently. Fuel efficiency is determined by its calorific value. The amount of heat energy produced on complete combustion of 1 kg of a fuel is called its calorific value, and it is expressed in a unit called kilojoule per kg. Calorific value of LPG is more than wood or coal. That is why LPG is more efficient fuel than wood or coal. Fuels are important, but increased fuel consumption has harmful effects on the environment. The smoke emitted by vehicles and industries contains unburnt carbon particles, which causes air pollution. It is advised never to sleep in a closed room with burning coal fire in it, as the combustion of coal will be incomplete due to less oxygen. The resulting poisonous carbon monoxide gas will be released, which can kill persons sleeping in that room. You must be aware of global warming. It is caused majorly due to carbon dioxide. The increasing concentration of carbon dioxide is due to combustion of fuels. Global warming leads to increased Earth's temperature. This will result in melting of polar glaciers, raising the sea level. It will result in flooding of the low-lying areas of the world. Another harmful effect of air pollution is acid rain. Rainwater that contains oxides of sulfur and nitrogen released from the industries and petrol engines in dissolved state, it may cause huge damage to skin, soil, standing crops, and buildings. There are ways we can reduce negative impact on the environment by choosing the right fuel. A great example of this is cars, buses, and auto rickshaws that run on compressed natural gas or CNG instead of petrol. CNG is a much cleaner and cheaper fuel. Summary. Let us summarize what we have learned. There are three different zones of a flame: dark zone, luminous zone, and non-luminous zone. Incomplete combustion of a fuel gives poisonous carbon monoxide gas. Increase in the concentration of carbon dioxide in air results in the rise of Earth's temperature. Acid rain contains oxides of sulfur and nitrogen in dissolved state.